How can I use line plots to help me play a game during indoor recess? In this lesson, you will learn how to solve a multi-step problem by using information presented in a line plot. Let's review. When we are looking at a line plot, we have to be sure that we know how to read or interpret the information. We have a line plot that's been created for the data in the table below. Each mark above the number on the line plot represents a piece of data. Understanding that each mark on a line plot represents a piece of data helps us make sense of the data and answer questions, such as, how many students are 50 inches tall? Since there are 3 marks above the 50 in our line plot, there are 3 students that are 50 inches tall. When working with line plots and fractional data, it is important to remember how to add fractions. When we add fractions, like in the problem below, it can be a common misunderstanding to add both the numerator and the denominator. However, it is important to remember that we're adding pieces of a whole. For the problem 3/4 plus 2/4, we start with 3/4 and add 2/4 to that. When we draw 3/4 in a model, we see that in order to add 2/4, we need another whole. And then we use one of the fourths from the 2/4 to complete the 3/4 and to create a full whole there. And so our answer goes from 5/4 to 1 1/4. Let's use what we know to help us solve the following problem. Jeremy is playing a game at indoor recess and he needs to build a barrier across the front of his desk, which is 2 feet long. He measured a few small objects that could be a barrier and he organized the data on a line plot. Does he have enough objects to build the barrier? If not, how much of the desk does he still need to cover? We know that we're trying to find out if Jeremy has enough objects to create a barrier for his indoor recess game. We know that Jeremy's desk is 2 feet long and that he created a line plot to help him organize the lengths of the objects he's gathered so far. Organizing the information in this way will be helpful as we solve this problem. We are also looking to see if Jeremy does not have enough of the desk barricaded, how much of the desk does he still have left to cover? Since we're trying to find out the total length of the objects Jeremy has gathered, adding up the total length of the objects is what we need to do. The line plot is helpful because like measurements are grouped together for easier addition. Since there are just 2 objects that are 1/8 of a foot, we can add those measurements mentally to get 2/8 of a foot. The same goes for the 2 objects that measure 2/8 of a foot in length. Their total is 4/8 of a foot. Now we can pull the final 2 objects' lengths from the line plot, 3/8 and 4/8. When adding multiple numbers in a problem, it can be helpful to add 2 numbers together at a time and then add those totals. When we add 2/8 plus 4/8, we get 6/8. And when we add 3/8 plus 4/8, we get 7/8. 6/8 plus 7/8 equals 13/8. 13/8 would cover 1 5/8 foot of Jeremy's desk. We know how much of the desk the objects cover, but is it enough for Jeremy's barricade? The desk is 2 feet long, and that is greater than 1 5/8 feet long, so the objects aren't quite enough. We are going to have to subtract in this problem because we need to know how much of the desk is left for Jeremy to barricade. In order to subtract, we need to convert our whole number and mixed number to fractions with like denominators. For 1 5/8 feet, the 1 foot equals 8/8 feet as well. So together, 8/8 and 5/8 equals 13/8 of a foot. Then for our whole number 2, that's equal to 1 foot plus 1 foot, and each foot is equal to 8/8 of a foot. So 2 feet equals 16/8 feet. So 16/8 minus 13/8 equals 3/8 of a foot left for Jeremy to barricade for his game. In this lesson, you have learned how to solve a multi-step problem by using information presented in a line plot.